So I'm probably going to spell both of these words wrong multiple times today. Parallel is one of those weird words where you always think, are there two R's? Are there two L's? What's going on here? So the first one, parallel slope. So the one thing to remember with parallel slope, okay, you have two lines. If their slopes parallel, they have the same slope. So when I mean same slope, I mean they have the same exact number. Okay, their slopes are exactly the same if they are parallel. An example of that, let's say line 1, the equation is y equals 1 half x plus 7. Okay, line 2, the equation is y equals 1 half x minus 16. These two lines are parallel. I don't have to draw these lines. I don't have to graph them. I don't have to do anything to them. If I said, hey, are these lines have parallel slope, perpendicular slope? You look straight at that number in front of x. If they're the same, they're parallel. Okay? So parallel lines have the same slope. Perpendicular lines you're going to have to remember a couple of terms here. These slopes are the opposite reciprocals. Reciprocal. Opposite reciprocal. Okay? So we remember our opposite from equations. Okay? Plus, minus are opposites. Positive, negatives are opposites. Multiplication, division. Okay? Reciprocal, we're thinking fraction. All right? They're flipped. Okay? So if you want to, in parentheses, I will just write flip. Help you remember there. Okay? So an example of these would be, let's say, line 1. I have y equals, say, 3/4 x plus 5. Okay, and the reciprocal to that for line 2, if they're perpendicular, we would have y equals negative 4/3 x, I don't know, plus 3. These lines would have perpendicular slope because they're the opposite. This is positive, this is negative. The reciprocal, this one's 3/4, the reciprocal would be 4/3. Okay, so if it's opposite flipped, then they are perpendicular. All right, so parallel lines have the same slope. Perpendicular lines have the opposite reciprocal. So let's look at a couple of examples, and we're going to determine, I'm going to give you some sets of points, and what we're going to do is we're going to determine whether these lines are parallel or perpendicular. So let's look at example 1. So you might get a question that looks something like this. It's going to say, determine whether line AB and line, let's say CD, let's try that again. Line CD are parallel, here we go, parallel or perpendicular. So we're given 4 points here. So point A, so we have 5, 3. Point B, let's say we have 8, 0. C, negative 7, 2. And D, 110. So I'll give you guys a second to jot that down. And again, if I'm going too fast, tell me, because sometimes, you know, us math teachers, we get in the zone and we just get rolling. We love the numbers. It happens. Some of y'all might be math nerds like me. It's all good, I promise.
Mr. Reed, I'm a math specialist Slope intercept.
Oh, you're all about some slope intercept. I love it. Okay, so the first thing we need to look at here, we have line A, B, and C, D. Okay, this means that A and B are on the same line and C and D are on the same line. Okay, we don't have to graph this. All right, so don't sit here and think, oh, we got to draw these big elaborate, graphs now. No, we don't. All right, so the first thing we're going to do, step one, we're going to find the slope of both lines. Okay, so I'm going to find the slope of both of these lines. And remember, the way we find this slope is from our slope formula. We got m equals y2 minus y1 over x2 minus x1. All right, so I know because it says line AB, A and B go together. So if I label these x1, y1, x2, y2. All right, let's just sub these in and determine our slope of our first line here. And I'll change my color here in a second so we can determine which one's which so it don't all look like it's meshed together. So I know y2 is 0. I just match them up here. Minus y1, which is 3, over x2, which is 8, minus x1, which is 5. And again, I can take these points and switch them. Don't get stuck on thinking, oh, this has to be x1, y1. It could be x2, y2, x1, y1. As long as my 1s are together and my 2s are together, okay? So we would get 0 minus 3 is negative 3, 8 minus 5 is 3, and when I reduce that, I'm going to get negative 1. So now, let's find the slope of my second line, which is CD. So these two go together. So I won't write my formula again. We'll just kind of leave it here for a reference. So x1, y1, x2, y2. So I'm going to label here. So x2 is 10, so I sub my 10 in, minus x1, which is 2, over x2, which is 1, minus x1, which is negative 7. 10 minus 2 is going to give us 8. And then 1 minus negative 7. These two negatives are side by side. So they're going to cancel each other and make a positive. It's going to give me positive 8. 8 divided by 8 is 1. Okay? So now, we're determining these are parallel or perpendicular. So when I look at my answers here, all right, what I'm noticing is negative 3 over 3 and 8 over 8 are not the same. Okay, so don't let that throw you off. We're going to look at the simplified version here. Okay, I have a negative 1 and a 1. But you might be saying, well, Mr. Reed, how can they be perpendicular if there's no fraction? Remember, I can always take this, I can put it over 1, and I can take this bottom one and put it over 1. We could put any whole number over 1 to make it a fraction. So if they're parallel, they'd be the same. Well, this is negative, this is positive. So we know that parallel is out of the question. So now let's look to see if it's perpendicular or not. Okay, has to be the opposite reciprocal. Well, this is negative, this is positive. They're opposites. Yes. Are they the reciprocal? 1 over 1. If I flip it, it's still 1 over 1. That means line A, B, and C, D, these are perpendicular. Okay, these are perpendicular. This one can be tricky, like I said, because of these numbers here are different. Okay, but once I reduce them, then we can see what our answer needs to be there. All right. So any questions on that one? All right, let's look at one more example. And I won't write this whole question, but we're going to stick with the A, B, C, D premise here. All right, so everything's going to be A, B, C, D. So example 2, we're going to determine the same thing. And let's say my point A is 3, 6. B is negative 9, 2. C, 5, 4. And D, 2, 3. Give you guys a second to get that down. And again, if I'm going too fast, just yell at me. So one key thing we're going to use here. All right, we're going to use our slope formula. M equals y2 minus y1 over x2 minus x1. Okay, that's the main thing we're going to use. Now, if you're not comfortable using the slope formula, can you plot these on a graph and find the slope of each? By all means, yes. I could draw me a little graph, plot these points, draw a line, plot these points, draw a line, and just kind of look and see what I got. Okay, you can do that. That's fine. All right, so remember, there's different ways of getting this information and solving this. So for line AB, I'm going to box this in. This might be a little easier to tell. We're going to use green here. Okay, so if I label x1, y1, x2, y2, so y2, we're going to have 2 minus y1, which is 6, over x2, which is negative 9, minus x1, which is 3. So 2 minus 6 will give me negative 4. Negative 9 minus 3, if I keep change, it's negative 9 plus negative 3, which is negative 12. And when I reduce that, I'm going to get positive 1 over 3. So for line AB, my slope is 1 over 3. So I'll look at CD, label my points, x1, y1, x2, y2. So when I plug that in, y2, we're going to get 3 minus y1, which is 4, over x2, which is 2, minus x1, which is 5. So 3 minus 4 is going to give me negative 1. 2 minus 5, negative 3. When I reduce that, those two negatives will cancel, leaving me with a slope of 1/3. Parallel, perpendicular. These are parallel. Their slopes are the same. So these two lines would be parallel. Their slopes are exactly the same. They're identical. All right.